Hey, welcome to another live Wells Tech training event. We are so happy you are here. Today we're going to be talking about blower motor resistors.
Yeah.
And they fail all the time, don't they?
Right,
It
yeah,
helps, keeps us in business. You know? That's
Right,
what we
yeah.
do.
Yep.
We make those things.
Yeah.
Yeah, pretty cool stuff. And what we have is a 02 Ford Escort.
Yep.
And the problem was no blower motor intermittently.
Yeah, intermittently. He could go into the dash and give it a kick and it would come back on sometimes.
Well, that could be a number of different things.
Exactly.
All right? So we're going to go through that today and show you exactly what that was, but we're not going to do it on the car.
Right.
We have a demonstration thing here that we have the whole system taken apart and wired up so we can show you exactly what's going on, and we'll be able to test it individually and show you just what's going on. It's going to be pretty cool.
Yeah.
But before we get there, let's talk about, yes, where is my t-shirt? Oh no, here it is. We're going to talk about the t-shirt giveaway, yes. And this is your question. All right, this is a typical blower motor resistor, right there. What is this right there? What does that part represent? Okay, that's your question.
It's a good one.
All right. All right. Now, today, where we're going to start out, first of all, it was the blower motor did not work at all. It was intermittently.
Yeah,
Okay.
at no speeds, low, medium, high, whatever, it didn't work.
Right. So that could be a number of different things. It could be a connection problem. It could be a blower motor that's going out.
Yep.
Could be a blower motor resistor with a bad connection.
Could even be a bad fuse.
Could be a lot of different things. Right. And so we're going to get down to it today. So how are we going to start? How are we going to do?
Just like every system, first of all, we verified that it wasn't working.
Okay. Yes, we did.
So,
Wasn't working. Next thing we did?
went out to Identifix, looked at that, and then we went and printed off our wiring
What
diagram.
did Identifix have to say?
Blower motor resistors are common, blower motors are common.
Blower motors are common. Yep.
Even the relay switch.
And the switches too. They have problems with those too. So
Pretty
Ford's
much.
got a lot of problems. With,
Pretty much the whole system.
yeah, you could pick just about any of those, and it could be causing an intermittent problem. So
Yep.
we're going to get down to the nitty gritty of it.
Yeah.
The interesting part of this, when we get into it, when we start testing it on the car, and that's really where I want to get to today. Okay. But before we do, let's just take a quick look at that wiring diagram one more time.
Okay.
And just let's walk through there.
Sure.
And just explain what's going on.
Okay.
You want to do that?
Yeah, sure.
Okay, go right ahead.
All right, so we bring up the diagram here. You can see at the top there in the middle, you see the blower 30 amp fuse. Our power comes down through that fuse, and when the relay is turned on, so whenever the ignition is on, the blower relay is turned on, sends power down to our blower motor.
Yes.
So by looking at this diagram, our blower motor, anytime the ignition key is on, our blower motor is hot.
Okay.
Now, what's interesting about this circuit, they're not all this way, but this circuit in particular is completely ground side controlled. Aside from the relay and the fuse, all the controls for the blower motor are on the ground side.
So what you're saying there is, depending upon how you control the ground, is going to determine how fast that scroll cage is going to turn.
Yep.
That motor is going to turn. Okay, cool.
So our power goes through our motor. Our load uses up the current in there, passes through the motor, and goes into our blower resistor. And then depending on which speed, depends on which resistor it goes through.
And where you have that's called the blower switch, where you have that positioned, is going to determine how much resistance you're going to send that current through.
Right, so if you're on low speed, you'll follow the wire down through all three of the resistors, down through the switch, and then through the floor panel mode select switch down to ground.
Right, it feeds back through there, through the switch, back up, down, and then through the...
Kind of a interesting design. They're passing through two switches to get to ground.
Yes, but it ensures that you're using the same ground, I guess, is what it's doing. And I would think that that's probably a thought process of the engineer. Plus, if you have if you have only one ground connection, then you're going to save money when you build this car.
I suppose, yeah,
right?
less wiring.
Yeah, and all that comes into effect with engineers, and we see that every day.
Right.
You know, money is important. Yeah, you could build this thing so it would never fail, but it would cost you more than your car.
Right.
You know, it's that kind of thing. So, you know, you try to save money.
Right.
And that's one of the ways that they did. It was just one ground connection. And actually, it's pretty smart.
Yeah.
You know, because it does work.
It does work great. And one interesting thing I had thought with this system on this Ford was that typically on a blower motor circuit, we see the high circuit on a different part not included with the resistor. So
Right.
when you're diagnosing a blower motor resistor, you go, okay, does it work on high? Okay. If it only works on high but no other speed, typically it's a resistor that's failed. That's usually the train of thought we go through.
Right.
But on this circuit in particular, if your resistor were to go bad, you would have no speeds at all.
You got nothing.
You have no
Right.
speed.
You have no speed, no fan at all.
Right.
Which can be pretty tough when you need it for the windshield.
Yeah, exactly. It's
So,
hard to defrost in this climate.
Yeah, and that's one of the reasons I believe that they make other systems so they at least run on low
Right.
if they're capable of it. You know, if they at least have a connection. So then you have something up on the windshield.
Right.
So, okay, real good stuff. Now, the other thing is, and I've had this question myself for quite some time, and if you looked at one of our old training sessions that we had with Mike Dale,
Okay.
and it was on the Ohms Law,
Oh,
okay,
yeah.
where we actually covered this. And we're going to demonstrate that today. Mike Dale was absolutely correct for once. He was correct. I hope you're watching this, Mike. And yes, he was absolutely correct. And when that blower motor is slowed down, the amperage draw goes up. And if you look at Ohm's Law, that's not supposed to happen on a DC circuit. It can't happen. Something else has to change. Your resistance or your voltage has to change too
Right.
with that
Right.
in order to make that happen. And that was my question to Mike. It's like, okay, Mike, if this fan slows down, I know the amperage is going to go up.
Right.
Tell me why. I don't understand it. Because you're telling me Ohm's Law works, and I'm telling you it don't. Okay, but we'll explain why that happens that way. And Ohm's Law really does work.
Yeah.
And we'll show you that. Actually, we're going to go over to our demo right now.
All right, let's go
Get
do
on
it.
over there and have some fun.
All right.
Okay.
All right.
Well, this is a pretty cool looking car.
Yeah, it's got 4 wheels on it.
Right.
Funny looking though.
Okay. All right. Let's explain what we have here first, so
Okay.
you can get familiar with what we're playing with.
Sure.
All right. First of all, we have a power supply over here, and this power supply is just like a battery, a car
Yep.
battery, and it's going to put out about 13.8. I think we have it set
Okay.
at. We can actually prove that out.
Sure.
And it's about 30 amps is what
Okay.
it puts out.
So
So, it's
just like
enough to drive the blower motor
Yeah.
and all that kind of stuff. And
Typical
kind of cool.
charging system
Yeah.
voltage.
Right.
So-
Okay. So that's what we got here. What do we got here?
Well, we got our blower motor here. Here's our original blower motor from our O2 Escort. We had to take the squirrel cage off of there, put it on the new one, so
Right.
the customer could have their
Right.
their heat. It gets cold up here.
Yep, it does.
So we have a blower motor here. This is out of a mid-2000s Nissan blower motor.
Which is the same. It doesn't matter. I mean,
Right.
for the demonstration, it doesn't. We don't have to have exact same one.
Exactly.
And the reason we have this one,
It fits on the table.
and we stole it from engineering.
Perfect. We had it in-house.
Right.
Excellent. And then we have our resistor right here. This is our blower resistor from our Escort. And then we have our blower switch here, which is a headlight switch. but
Headlight knob. Yep.
it's the blower switch with a headlight knob, right?
Right.
So, and then we have it running directly to ground. If you saw in our diagram, back then we showed that it would go through
That's a
another
good
switch
point.
to get to ground.
Yep.
But to cut down on the complexity of all this wiring mess here.
Yeah, and it really isn't necessary to have
Right.
that switch in here. Usually, systems do not function that way.
Right.
Ford uses that, but I think they're about the only ones.
So we have an operational blower system without having to crawl under the dash.
Okay.
So let's just show how it works. Let's start with showing that voltage.
Yeah, let's
Just to
show
show
them
that
that
we
we
have-
do have the correct voltage.
Exactly.
Let me click on here.
All right.
When I click on, this fan is going to turn on. It should.
Just like turning on the ignition switch.
Just turning on the ignition switch. That fan runs all the time.
All right, let's see how
And
that
the voltage we have is 13.87, so 86. So we're right on.
That sounds good.
Right. Okay.
All right.
And click this off again.
So what do we want to do now?
I think what we should do is let's take a look at the amperage draw. Let's explain
Okay.
what we're going to do there. We have an amp clamp here, a regular
Right.
old amp clamp.
Yep.
And we're going to set it on 1 millivolt, 10 milliamp division.
Right.
Okay, and I'm going to hit the 0 button right there. So
right.
we're all zeroed. We're set to go. And I'm going to clamp it around the feed wire to the blower motor.
Okay, and we have
And
it
that's
plugged
exactly how you should do it on the car, too.
Okay, perfect. And then we have that plugged into our lab scope here, and our lab scope's going to read the voltage. So our amp clamp is converting amperage into voltage,
Right.
giving it to our lab scope. Our lab scope is going to graph our voltage here. Then we need to convert it back into amperage to be able to determine.
Yes, and
where we're at.
I'm an easily confused person for some reason, I don't know why. So I get confused if I'm going to use my meter and this amp clamp.
Okay.
And before we get done today, we
Yep.
need to show that.
Sure.
Because a lot of guys are going to grab their meter before
Right.
they grab their lab scope to
Exactly.
get up underneath there. But the lab scope works good for us in this case, just to show exactly what's
Yeah,
happening.
so we can graph it. And so
Yep.
why don't we go ahead and do that?
All right, let's crank her up.
All right, let's see what we got. So you can see right away when he turned it on there, the voltage came up, and we're at about between 0.3 and 0.4. I would call it 0.4 just for ease of conversion. So at 0.4, this is reading volts, remember. We're going to convert that into amperage. We're going to just move our decimal point over 1 point, so we're at 4 amps.
Right, we're at 4 amps at this point. And
Yep.
I'm going to crank it up to second.
All right, I'm going to actually back out here and up our voltage. We're on a 1 volt scale right now.
Okay.
I'm going to go up to 5 volts. And, okay, so now we're at, I would call it about 6 amps.
Okay,
Go up again.
go up.
We are at now about 10 amps or so.
Now we're going to go to high.
All right. And I'm going to stop it right there.
Okay.
So we're at, I would call this about 17 amps to run that blower motor on
Okay,
high.
I'm going to shut that off. Right, yeah. Let's go back to that scope
Yep.
pattern again and take a look at that. All right, explain what's happening there.
Right, so this right here is our speed 3.
Yep,
We turn it on to speed 4 and we get a spike.
right.
But now is this the actual true spike of what it's spiking at?
You know, according to this meter, it is.
Right.
But if we got a meter, if we got a scope that was like our engineers use, okay, we would see a higher spike there.
Because it's
this-
faster.
right, it's faster, and this is not picking it up. As a matter of fact, about 20 years ago, we were having problems with our starter solenoids
Okay.
on Fords. Before you were born.
Hey, I got a few years on that.
Yeah.
Come on.
Okay. So the engineer and I wanted to find out how many amps does a starter actually draw?
Sure.
You know, when you do the initial engagement. And what we did is we took an old 76 Ford truck, parked it out in the cold,
Okay.
and brought his lab scope, a real lab scope.
A
and put
delicate lab
A
scope.
delicate lab scope, and did it. And we were drawing 12 to 1,400 amps. on this.
1,400?
100 amps.
Wow.
And if your solenoid isn't made out of the correct material, the discs that are in there that actually make the contact, they will stick from time to time.
Okay.
And that's what we were experiencing, so we knew we had to change the material and stuff like that.
Okay.
But it was amazing how many amps that drew. I had never dreamt it'd be that
Wow.
high. And now that was a morning that was probably 30 degrees.
Sure.
At 20 below zero, it could easily double.
Right.
You know, so it's amazing how much that draws.
Right, so potentially here on our graph, we could be looking at a spike over 30 amps.
Very easily.
And we have a
very
30
easily.
amp fuse, so why
Right.
does the fuse not blow then?
That's why you have slow burn fuses. That's what that means. When they see the initial high amperage over the rated amount, they're not going to immediately blow. They're going to delay.
And when we say slow burn, we're talking like milliseconds here.
Right.
Not-
And then that spike only happens for a microsecond.
Right.
But if it's not set up, if the system isn't set up to handle it, it's going to fail.
Right.
And that's what we're looking at
In
here.
terms of the way how quickly the fuse operates, if you run
Right.
35 amps into that fuse, in the time it takes you to touch it to something, it'll most likely blow.
Right.
But this spike happens so quickly that
Right.
it's got enough time.
Yep.
And then after our spike here, if we look at our scope, you can see our voltage or our amperage spikes up and then drops back down to a common amperage, I would say around 16 to 17 amps.
And it's got oscillations characteristic of an AC circuit.
Interesting.
Yes, we'll talk
Very
about that
interesting.
now.
Yeah. So we're at 16 amps,
Yep.
but we don't know if that's good. We don't have any sort of spec. There's no spec posted for the current draw on this motor.
And sometimes you can find a spec for these, but normally it's not there.
Right.
So what you have to use is a rule of thumb.
And
go ahead.
we talked about that in a previous class, right?
Yep, we have. Where this has got a 30 amp fuse on it, and it shouldn't be over 15 amps.
Right.
Rule of thumb.
Right.
Okay, so that's a gray area. Don't take that as gospel. If it's 15.1, don't be going in there replacing that.
Right.
Okay, so let's just go in and where do we want to go?
Well, let's just say
don't know
this thing came
Let's
in
go
with
over
our
here.
intermittent problem.
Right.
Say the first thing we did was hooked an amp clamp up to it. It was functioning at that point. Hooked our amp clamp up and saw that we had 18 amps. Okay, our circuit is a 30 amp circuit.
Right.
We're going to now look for any other problems related to, is that 18 amps too high?
Right. That is
So
correct.
we go in and look at our resistor here,
And
you
that's
can see.
and your point is completely valid. You can't just go, when you're talking about rule of thumb things, you can't just go by what your meter is telling you.
Right.
You got to use, and in this case especially, you have to use your other senses, other things that God gave you. And one of the things that I would always do is if I brought a car in for even just an oil change or something, and it sounded like that blower motor was rough.
Right.
I would take, and if I could get to it, I'd put my hand on it. And once you put your hand on it, you can feel whether or not that bearing is going out.
Okay.
Right?
Right.
And it may not even be drawing too many amps at that point, but that's enough to condemn it.
Yeah.
Because
I agree.
it's going to. It's
Right.
going to fail. Okay, so the moral here is, repairing a car many times is still a black art. Meaning, you can't just go by what your scopes are telling you. It's kind of like doctors.
Sure.
It's the same thing. Just because the results are saying this, it may not be the reason or the
Right.
cause of the problem. You have to use your senses also and your experience.
Right.
And that's where that all comes in. So
Right,
really
right.
good stuff.
So
All right.
in our case here, in our example, if we go ahead and pull up a picture of this connector here, you can see this thing got melted.
Yep, it did.
It definitely is burned. It's giving us an intermittent connection because it can wiggle around on there.
That's correct.
And that's caused by that excessive current draw.
Right.
When you have current draw over what it's supposed to be, over spec of what the wiring is meant to handle,
Yep.
it creates an excessive amount of heat and melts this thing down.
And I know, you've been explained many times the flow of electricity using a garden hose. And I'm going to tell you one more example of that. Okay, just imagine this. We have 5 pounds of water pressure on a garden hose, right? What's the weakest point? Is the connection.
Connections, yep.
The connections are the weakest point. And it's the same thing with an electrical circuit. The connections are the weakest point. That's where you're going to have your highest resistance.
Okay.
When you're expecting the current to pass through from one terminal to another.
So
And go ahead.
that's why these things get melted then, is because that's the highest point of
And
resistance.
you're using your sense of sight
Exactly.
to determine that. Take a look at it and just see. If that's burned up, you got an issue. There's something going on. You need to take a look at it. Something is slowing down or causing more amperage to pass through that circuit than what it was designed for.
Right.
Okay. And doing so, something is slowing down this squirrel cage, usually.
Right. If it's tighter bearings or bearings are wearing out or there's a restriction in airflow.
Right, you got a cabin air filter that's
Right.
never been replaced.
Yep.
Tommy was playing around with money and the defroster holes, and you open that up and you find out you can make your house payment now, all that kind of stuff.
Right.
So yeah,
Yep.
we've all run into it.
Yeah.
We've all seen it, and it happens all the time. So for some reason though, there's more amperage flowing through that circuit than what
Right.
should be.
So
And-
going off of our rule of thumb here, being that we're at 16, 18 amps, and we have a melted connector here, I'd be putting a blower motor in this car.
Absolutely, no doubt.
Because
Yep.
it is over our spec of what we go off of.
And our senses told us there was an issue. There
Right.
is another issue there.
Yep.
Yep.
This is the cause of the intermittent fault is the bad connection, but it's caused from our high amperage draw.
Right. Now, another problem is, well, it's my problem, is, okay, if you got a DC circuit,
All right. Well,
and
just,
oh, you want
let's
to go?
yeah,
okay.
let's go one other place before we get there. Let's talk about
Right.
this.
Oh, yeah. Let's talk about that.
Let's bring up that picture of the question that we asked. If you go ahead and bring that up. We asked about what that part circled on the diagram was, right there.
Right, there it is, right there. Okay, what is the answer there? That is a fuse.
Looks exactly like a fuse you'd see
That
in a fuse
is
box,
a fuse,
right?
but it isn't a regular kind of fuse.
Yeah.
But anybody who answered fuse or thermal fuse or anything like that, I will accept that answer. And so there you go. That is a fuse.
Right.
Now let's find out what kind of fuse it is.
Right, yeah, that's not a fuse that you're going to see in your fuse box or under the dash or
No.
whatever. This is going to be a thermal fuse that's designed to melt down at a certain temperature. That's why the resistor's mounted in the heater case, so the air goes past it, cools it, keeps it nice and cool.
It's in the airflow.
So what we did is, here, why don't you go ahead and bring that picture up.
Yep.
So this is what it looks like. This is the original resistor.
Right, and you're holding a little screwdriver there at the end of it. You always
Yep.
see a little colored, looks like plastic.
Yeah, yep.
Whatever it is there.
So, well, because we have an awesome job, we went ahead and melted this thing down
Yep.
to see what it would do. So we took our
And we
heat
like
gun.
to blow things up.
Exactly. And if you bring up the last picture there, you can see what it looks like once it's been melted down. So right now, our thermal fuse has failed. Our circuit's now completely open. We have no path to ground.
Right.
Our blower motor's unable to function.
So I had a question, and those guys aren't in here today, but we do have a few engineers in here, and they may critique me on this, but which they always do, which I appreciate too.
Of course.
All right. My question was, how does this work?
Right.
How does that work? How do you determine what temperature that's going to be? And what they told me is solder comes with different compounds, and being different compounds, it will have different temperature qualities.
Okay.
Okay, where it's melting, that
Sure.
type of thing. Okay, and the other part of it is, so you got to find the right solder. The other part of it is very interesting. Inside of the cylinder isn't just one hole all the way through, same size hole all the way through
Okay.
to put the metal or put the wire through. It's actually tapered down in areas. Okay, and the reason for that is the more you taper it down across that wire, the quicker it is going to fail.
Okay.
The lower temperature it's going to take to fail because it transfers more heat that way. Very interesting. So that's how you set it, and these are set around 200 degrees, I think is what
somewhere right
Dana
around
said.
there, yep.
Right around 200 degrees to go off. So if it's 200 degrees for 5 minutes, this thing's going to melt. Because it took a while to...
Right, yeah,
you just didn't hit it with the 200 degrees.
Yeah, it wasn't an instant thing. Again, a slow burn type of fuse.
Right, which is pretty neat. How does that help you fix a car? Well, if it doesn't work at all,
Right.
you know, it could be that that's burned out.
What I find interesting is we're talking thermal and we're talking heat, and say we ran this blower motor on high and this was out of the heater case. It would most likely melt down our thermal fuse.
Yes, because those resistors get
Right.
very hot.
Yep, but also we can talk in terms of current. As current increases, temperature increases. If you have an excessive amount of current passing through this fuse here, it can melt that down.
Yes, it could, like a bad blower motor.
Exactly. So is the resistor going to be the root cause of a problem? Potentially not. The resistor could
Probably
have failed.
not. Those resistors aren't going to fail.
Right.
I've never seen one fail.
Something caused it to fail.
Something caused it. Yep.
So that's why we hook our amp clamp up and we take our reading, and we can really determine then.
That is
and
correct.
Make sure we don't have something coming back.
Right. Okay.
Well,
Now can we talk about the cool stuff?
we can talk about the cool stuff
All right,
now.
good. All right, we're going to talk about Ohm's Law. And
Don't run away.
right. Okay, Ohm's Law. And if you came into we had a training class on that with Mike Dale.
Okay.
Because I told Mike Ohm's Law doesn't work on a car. And
Sure.
he was going to prove to me that it did. And he did. So I was wrong again. But my question to him, and the reason why I didn't feel it worked on a car, was this. Okay, if you apply Ohm's Law to this, and I run this motor, and I put a rag on here and slow this motor down, the amperage draw goes up.
Okay. Well,
If you apply that to Ohm's Law, voltage, right, or
Yeah.
resistance has to change.
Right.
I didn't change anything, but the amperage changed, so that cannot be applied to Ohm's Law. It's something different.
Right.
And the difference is actually when it goes from a battery, which is DC current, and it goes through a motor like this, it gets converted to AC current.
Okay.
And AC current does not, Ohm's Law does not pertain directly to AC current like it does DC.
so I can still believe Ohm's Law then.
You can still believe Ohm's Law, and it still does apply.
All right.
And I was wrong again, but let's demonstrate this.
Yeah,
This
let's
is
do
pretty
it.
cool stuff.
All right. I'll get this set up here.
Oops. There we go. Kick her
Fire it
on.
up, okay. All right.
All right, we'll kick her up on high so you can really see. Oops, look at that. See, it was a bad intermittent.
Look at that.
Oh.
You dropped connection again.
Let's do this again. You can see the resistance, or the amperage goes up as the resistance
There you go.
increases. There it is. Do it one more time.
There we go. That thing's really spinning.
Yep.
So you can see here, we'll go back to our scope, you can see that our amperage increases by, I'd say almost 5 amps.
Yep. By just putting the rag on there.
Yeah,
So there's
restricting the
proof.
movement.
I mean, when you slow down that squirrel cage, no matter if it's a air filter or whatever it is, it's going to raise amperage. And it raises it drastically. I didn't push on this to really slow it down either. We could have raised it up a lot higher if we wanted to. But if you're talking about cooling systems where you got a fan or whatever, starter,
Same thing.
it all applies.
Yep, you raise that amperage, you increase temperature throughout the circuit, and you melt down your weakest spot.
And how many times do you see those wires burning going up to the cooling fan?
Yeah.
All the time, and that's why.
Exactly.
That motor's drawing too many amps.
Yep. You got to fix the root cause of the problem.
root cause of the problem.
We could put a resistor and a connector in here, but it would come back a few weeks later, same problem.
As you can see.
Yep.
Yep. Okay.
Perfect.
Very good. All right. Do we have any questions?
I don't see anything. No. No
Okay.
questions.
Okay. If you answered that question correct, if you said it was a fuse or a thermal fuse or whatever, you want to bring up my email address, Glenn, and you send me an email, mark.hicks@wellsve, and we'll get you out a T-shirt tomorrow.
Oh, one other thing before we.
Send your shirt size and mailing address, please.
One other thing just before we go. Let's just hook this up to the meter.
Let's hook it up to the meter. Let's show them how to do it on the meter.
Okay, so
'Cause
being
that's where most guys are they're gonna use their meter underneath the dash like that, anyways.
Yep, for sure.
Okay, we're
So-
doing nothing different with the amp clamp. I'm gonna clamp it around the same spot again.
Being an amp clamp, we're going to put it into the amps peg of the meter, right? Mm-hmm. Yeah, that's not going to work.
Okay, explain that because
Right.
that is the confusing part.
Right. So if we were to put this in the amps right now, we would get no reading at all.
That is correct.
Our amp clamp is converting the amperage it's reading into a voltage reading. So we have to make sure we hook up to our voltage.
Put it into the volt slot.
Just like if you're doing voltage drop or checking
Right.
a battery state of charge, something like that.
Yep.
So why don't you go ahead and fire this
Don't
thing
feel
up.
bad if you've done it wrong.
Yeah. So right here we're at, and again, we got to move the decimal point over. So we're at 3.9 amps on low,
Right? Let's crank her up.
6.8 amps. And you can see it does spike and then settle
yeah.
back down. There we go, 16.5 amps.
Right.
So
There
this
you
is
go.
probably the way I would do it. I would use a meter.
Absolutely. I would too.
The lab scope's nice because you can graph it over time, but
Yep.
this works just as well. And
Just make sure you plug it into the right spot.
right, yeah, you'll use that amps connection doing parasitic draw or
Right, that's a
something
good
where you're
point.
installing it into the circuit.
Right, where you're actually making the meter part of the circuit.
Right.
That's where you want that. You want to be into the amp circuit.
Yep,
All right. Anything else?
I think that sums it
All
up.
right. Thank you for being there. Without you being there, we would not be here. We do appreciate it, and we'll see you again next time in Wells Tech Garage.
See you then.
All right. What are we gonna burn?